We need to find the complete integral of this equation by Charpit's method. Let's take f to be equal to taking the z to the other side, writing f to be equal to p square x plus q square y minus z. For Charpit's subsidiary equations, we need the derivative of f with respect to x. We need the derivative of f with respect to y. We also need fz, fp and fq. Let's find out these. Taking derivative of f with respect to x, so that is p square. With respect to y it is q square. With respect to z it is minus 1. With respect to p it is 2px, and with respect to q it is 2qy. Easy. Now using the Charpit subsidiary equations, these are Charpit subsidiary equations. We need to put all these values, the details over here. So dx divided by fp, what is fp? It is 2px equals to dy divided by f. So this is 2qy equals to dz divided by p multiplied with fp. This is fp, so this is 2p square x plus q multiplied with fq. This is fq, so this is 2q square y, and is equal to dp divided by negative of fx. Fx is p square. So this is p square plus p into fz. Fz is minus 1, and when multiplying with p we get minus p, right? And dq is equal to negative of fy. It is q square plus q multiplied with fz is negative 1, so this is minus q. Now we need to choose the ratio so that we can get the value of p or q or the relation between these two. What ratios are easier to choose? Let's write the denominator of this to be, when multiplying with negative sign, it is p minus p square, and this is q minus q square. Okay, now let's check. I'm interested in taking these two ratios. I'm having 2px over here and p over here. So I need to take the multiplier as 2x with dp, and I need to take the multiplier p square for dx. So if I take p square with this denominator, I'm getting 2p cube x, and if on multiplying 2x I get 2px minus 2p square x. I'm having extra p over here, so if I multiply also p with this, I get 2p square x and 2p cube x, so that I can cancel these two, right? So let's take the multiply 2px for this and p square for this. So I'm managing the numerator to be p square dx, adding this to 2px dp, and in the denominator I get, okay, from here we get 2p cube x, plus from here we get 2p square x minus 2p cube x. In similar way, I am interested in taking q square dy plus 2qy dq divided by, similarly I get, okay, these two cancelled out, and by symmetry I write here 2q square y. Okay, from here I can cancel this 2 also. How to write this numerator to be? It is the derivative of p square x, isn't it? First function derivative of second plus second function derivative of first. Am I getting back this numerator? Yes? This is 2px. Don't confuse. Okay. So writing the numerator as the derivative of p square x divided by p square x equals to, here also, derivative of q square y divided by q square y. And now integrating both the sides, I get, because I need to integrate with respect to p square x, So it is log of p square x equals to log of q square y plus log of b, the constant. Here log of b is the constant. Okay, so this is log of p square x equal to log of, by applying the property, it is q square y into b, right? And from here we get p square x to be equal to q square yb, right? And now we need to find the complete integral. We get the relationship between the p and q. And now to get the values of p and q, let's use the given equation. What is the given equation? It is p square x plus q square y equals to z. So using this given equation, we can get the value of p and q. Okay, what is the relation we got? P square x is equal to q square yb. We have p square x is equal to q square yb, and I am putting p square x over here. So it is q square yb plus q square y equal to z. So from here I get q square to be z divided by y into b plus 1. Yes. And q is equal to the square root of z divided by y into b plus 1. Similarly, we can get the value of p to be square root of bz divided by b plus 1 into x. So from these two values, we are going to use the equation dz equal to p dx plus q dy to get the complete integral. We need to get the value of z now. So for that, just put the value of p and q over here to get the value of z. Alright, so it is dz equal to, what is p? It is square root of bz divided by x into b plus 1. Dx plus, what is q? It is the square root of z divided by y into b plus 1. Because square root of b plus 1 is common in the denominator, let me take that to the numerator of the left hand side. And also I can take the square root b outside from the numerator. Outside from the numerator, it is now the square root of z divided by x dx plus also the square root of z divided by y dy. And now taking the square root of z common from the numerator and taking that to the denominator of the left hand side, square root z dz equals to square root b 1 divided by root x dx plus 1 divided by root y dy. It is very easier to integrate now. Integrating this, because square root b plus 1 is constant, so now integrating 1 divided by square root z. So it is square root z divided by 1 divided by 2 equals to square root b. Okay, integrating 1 by root x, that will be root x divided by 1 by 2. Similarly, it is 2 root y plus the constant, let me take that to be 2a. Cancelling overall 2 from the numerators, and now we get square root of z into b plus 1 equals to square root of bx plus square root of y plus a to be the required complete integral for the given equation, where a and b are arbitrary constants. Right? Okay, thank you.